Okay, welcome back to class. Now we're looking at the range of a linear map. We have discussed the kernel of a linear map. Now to flash back to what I discussed with us, so I said that the kernel of a linear map actually speaks to the domain, right? Now for your range, it speaks to the codomain. I said that the kernel of a linear map is actually a subspace of your domain V, but the range of a linear map is actually a subspace of your codomain W. So I take that again. The kernel of a linear map is a subspace of your domain V, while the range of a linear map is a subspace of your codomain W. So let's read together. So let T be a map from V to W, a linear map, right? So the range of T, denoted by like this range of T, is actually the set. It's also a set like your kernel, the set of all vectors W. Can you see a small w? If you compare it to kernel, you know we said a small v. So you see the difference. Small v, small w, that is telling you this one speaks to the codomain, right? Such that w must be equal to T of v, right? Okay, so for some small v which is an element of v, that is the range T, mathematically in an equation set is defined this way. W must be an element of W, capital W, such that W is T of V for for V being an element of capital V. So this is how we define the range of a linear map. Now take note of these things. Number one. Okay, so the range, just like the kernel, the range is never empty. The range is never empty, just like in a kernel. The range is never empty. Okay. Number two, note that while the kernel I think I said that already, while the kernel of the linear map while the kernel of a linear map, okay, is a subspace of the domain, comma, the kernel, the range of a linear map, on the other hand, is a subspace of the codomain. Is a subspace of the codomain. Okay, don't forget this. This guy is the subspace. Kernel of a linear map is a subspace of the domain V, while the range of a linear map is a subspace of the codomain W. The third note. Now the dimension, we discussed dimension. Dimension of your range. The dimension of the range of a linear map. Remember, for kernel, we said the dimension of the kernel is called nullity, but for the range, dimension of the range of a linear map is actually called rank. The dimension of the range of a linear map is called rank. Okay, and then it is denoted like this, capital R of T. And finally, 4. Well, I think that's all. That should be all. Not 4 now. Okay, that should be all. So this implies that your dimension dim T is actually equals to the rank of T, or R of T, is actually equals to dim range of T. Okay, dim range of T. So once you take the dimension of the range of T, that is the number of elements in the range of T, you have found the rank of the linear map. So this is basically the range of a linear map. It's very straightforward. Unlike your kernel, let's quickly compare them. Unlike your kernel, we define the kernel of T, do you remember, KR of T, to be the set of V, which is an element of capital V, such that T of V equals to the zero vector of your codomain, right? And then we said that the range, on the other hand, is actually speaking towards our codomain, which must be an element of capital W, such that your T of V must be equals to what? W, or W equals to T of V, right? For every V being an element of capital V. So you can see the difference. Now I wrote them side by side so you can look at the difference between kernel and range. Kernel speaks to your domain, range speaks to your codomain, as you can see. And the kernel is simply speaking to the zero vector of your codomain, right? So T of your domain, the T of your domain must be equals to your codomain, while your range is saying that it must be equals to the zeros of your codomain, okay? While your range is saying that there must exist a particular set of vectors W, which is your codomain, right? And your codomain must be equals to your T of V. See the difference? They are quite similar, but they are not, obviously not the same. So in the next video we'll see examples that would further help you understand this concept of the range of a linear map. Bye for now.